Good day and welcome to today's STS-134 ULF-6 mission status briefing. With us today are Derek Hassman, the lead space station flight director for the mission, and Allison Bollinger, who is the lead EVA or Spacewalk officer for the flight. We'll start off with some opening remarks from both of our briefers, and then we'll move on to question. Derek?
Okay, thanks, Kelly. Good morning, everybody. It's great to be back here today to talk about another very successful day in the STS-134 mission. Of course, the primary objective today was conducting our first spacewalk, EVA-1, and overall it went very well. We did encounter some issues with Greg Shamatov's suit, which we'll talk about in more detail, but got a lot of good work done today on the EVA, and we did have to defer a task at the end. We'll talk more about that, but we think we can get that later in the mission. And what I'd like to do is just hit the high points and then hand over to Allison to talk more about the details of the EVA. First out the door, we retrieved 2 DoD materials payloads that we refer to as missies. We grabbed 2 of those off the truss, brought them back to the payload bay, stowed them for return. Then we installed a new missile on the truss, which we got feedback just before we came over that it was activated and operating well. We installed a CETA light on the truss. We installed a solar alpha rotary joint cover that was left removed from a previous mission. And we also were able to successfully set up for an ammonia cooling loop refill that we're going to do on EVA-2. The activities on this EVA didn't involve any ammonia QDs, but we did connect jumpers and vent the nitrogen pad for those jumpers. So it was important that we get this done in order to put us in a good position for EVA-2. The last task on the EVA involved the installation of antennas that were going to allow external payloads and hardware to communicate wirelessly with computers inside the station. We got the antennas themselves installed, but the cabling was going to require us to remove micrometeoroid debris shield from the laboratory module. Right at the point that we were going to start that, we got indications on the ground that there was an issue with Greg Shamatov's CO2 sensor, his carbon dioxide sensor, and we've got written pre-flight decisions that we call flight rules that govern how we deal with these type of situations. In the case of this CO2 sensor, it requires that we make a more conservative estimate of the capability that Greg Shamatov has left in his suit. So we did those calculations, compared that to the work that we had in front of us, and we made the decision that we weren't going to continue with that portion of the task. So we did some cleanup work and some get-aheads, and we called it a day. And we're looking ahead at future EVAs to understand better where we're going to fit that task. It's very unlikely that we're going to change the EVA-2 timeline. More likely that we're going to look at the EVA-3 timeline in terms of a place to put that task. And with that overview, I'll hand it over to Allison.
All right, thanks a lot, Derek. So first of all, I'd like to say I couldn't be more proud of the crew and my team here on the ground for the almost flawless execution of this EVA today. It just goes to show what extensive planning and ground coordination pays off, how it pays off. So Derek pretty much stole my thunder and all I had to say about the tasks today. As he mentioned, we got out the door and we started out with the missies, or the material ISS experiments. We put those back in the payload bay. We retrieved Missy 8. We got that installed. It was taking Greg Shamatov a little bit longer on some of his tasks on the CETA light install that Derek mentioned. So once again, exemplifying how well our team works together, we were able to make a real-time call to go ahead and transition the installation of that solar alpha rotary joint cover from, it was originally planned for Greg Shamatov, and we were able to just flawlessly transfer that over, and Drew Foystel was able to install that. So it worked out, the timeline worked out really well. And so, and another one of the reasons that we did this was as we were starting to get data on the ground on Greg's met rate and also looking at his O2 tank pressures, we started thinking that in order to put ourselves in the best posture to be able to stay out as long EVA as we need to get these tasks complete, that we would go ahead and complete an oxygen recharge of Greg's tank. So we were able to send him back to the airlock while Drew was working on installing that Sarge cover to allow Greg to do that O2 recharge. So then both crew members headed out to the port side of the truss and worked on installing the jumper that spanned the Sarge. Then we vented the nitrogen from the P1 ATA panel all the way out to the P5 junction. We vented that nitrogen, and then Drew headed further outboard to vent the nitrogen from the EAS jumpers, as we call them, the final jumpers that will lead to the photovoltaic thermal control system, or PVTCS, that we will be refilling with ammonia on EVA-2. Once Drew was complete with that task, Greg temp stowed that jumper so it's partially installed on the P4 side and wire tied out there to allow rotation of the solar alpha rotary joint between the EVAs. We then headed off to the lab, as Derek mentioned, to install those antennas. Greg worked diligently to remove those handrails and install those 2 new antennas, while Drew worked underneath the lab to start setting up the work site and setting up the cables. And it was about that time, it was actually a PET, or phase elapse time, into the EVA of 4 hours and 30 minutes that we heard the words from Greg saying, "I got a CO2 sensor bad" message. So that was what forced us to eventually kind of replan the end of the EVA. So we had set ourselves up nicely to begin with by doing the O2 recharge on Greg, but then it got the better of us when we had the CO2 sensor fail. So we had actually discussed this on the ground, different breakout points in the EVA. So the crew and the ground team were definitely ready to go ahead and say, let's not open that micrometeoroid debris shield and break into those cables. Let's just go ahead and temp stow it and put it on a future EVA. So everyone understood that this was a possibility, and so I'm very glad that we had those discussions on the ground. So we spent the rest of the EVA. We had Greg cleaning up the work site and mating a few additional connectors, and then we sent Drew off to the airlock to the vent tool extension bag to perform some relocation of tools in preparation for the ammonia fill on EVA2. So with that, we ended at a PET, I think it was 6:19 was the duration for our EVA. And like I said, I couldn't be more proud of the crew and the team. That's all I have.
Okay. Thank you. We'll start off with questions here at the Johnson Space Center, and then move on to some other locations, including the phone bridge. Seth.
Seth Borenstein, Associated Press. Allison, in terms of the problem with Greg's suit, have you determined the cause for the sensor? I mean, is moisture the leading suspect, it sounds like? And 2, did you determine whether there was any excess CO2 in it or not?
I guess that's a good point. So when the crew member receives that message that says CO2 sensor bad message, they initially flip to their cuff checklist, which basically tells them that the crew is now responsible for monitoring their own CO2 symptoms. So we made Greg aware of that, and we said, let us know if you experience any CO2 issues, and he never reported any. And we, up until that point, we had every indication to believe that his LIA, or the contamination control cartridge in his suit, was working perfectly nominally. So everything was fine from that aspect. So we told him that he was primed for the CO2 symptoms, and as you mentioned, moisture is the leading cause. This is an infrared sensor, so if you get a little droplet of water in it, it causes that sensor to go off scale high, and that's what triggers that CO2 sensor bad message. So we have seen this before on other EMUs, including this particular EMU when it was used for the pump module activities last summer. So we have seen this before, and it is due to excess moisture. And Greg did mention as he was egressing his suit that there was excess moisture in his suit. So we are looking into the cause of that. And hopefully we'll be able to solve that problem for his next EVA, which is EVA4.
And that EMU isn't used until
EVA4, that's correct.
And in terms, and you didn't see any indications of afterwards of excess CO2.
By then, we had lost insight into it, and so we were just relying on the crew member's feedback, and he didn't report anything.
So if you put this into EVA3, what was missing, how much does that add to your timeline? Is it 40? I mean, I remember this was a 45-minute task. That's
correct. It's a 45-minute task, and so we'll add about that time plus maybe a few minutes on either end for the translation to the work site. So between 40 and maybe 45, or between 45 and an hour that we would add.
So forgive me, I don't remember how much the EVA3 timeline is.
It's a full 6.5-hour EVA. So we still have to have future discussions about overall mission priorities and what tasks we will need to defer from this EVA.
Can you go just to 7.5 hours?
It depends on how consumables are looking. So like we always plan our EVAs to 6.5 hours. So we'll just have to see how consumables go on the day. And we have to take into consideration, other flight day aspects, crew day length durations. And I'm sure Derek could answer more on that. But sometimes we can go longer than 6:30, but we just have to see. But before the EVA, we will not plan to longer than a 6:30. So we will have to defer some task from EVA3 if we were to add that task to this EVA.
Okay, we're getting the microphone to our next questioner.
Philip Sloss with NASASpaceflight.com. I'll throw in here. When you were getting out of the suits, it looked like they were looking at the Greg's gloves a little more closely? Was there something that they saw there that was reported?
I think that was just part of the normal. After each EVA, we take extensive glove photos when the crew members are still pressurized, so we can look if there was any damage to the RTV or any damage to their gloves. So that was just standard post-EVA work.
Thanks. Okay, Mark?
Thanks, Mark Carreau for Aviation Week. I think it's for Allison. Where is this sensor? And when you say water, do you mean like cooling loop water or perspiration or unknown or?
Where is the sensor? Somewhere in his backpack? I can't tell you. It's somewhere in the life support system on his back.
Good.
And the water can be many things. It could be either just exhalation water, or it could be perspiration, or it could be from the cooling loop itself. There is sometimes water in that can be through when the fresh air comes over to the crew members. It can also have some water in it. So we're not really sure where the water came from.
And I realize you guys have gotten pretty good at troubleshooting various parts of the spacesuit and refurbishing and so forth on orbit. Is this the kind of thing that you can do you think, or is that kind of to be determined?
Actually, we have just recently started flying new CO2 sensors, and they are currently developing a procedure to remove and replace that CO2 sensor, but that procedure has not yet been developed. So we're just looking for post-shuttle retirement, ways we can maintain suits on the space station. So that procedure isn't ready to go yet.
Okay, Rob?
Hi, Robert Perlman with CollectSpace.com. With regards to the wireless antennas, if you weren't able to get to that, what systems would not be reachable via, or what does this, what payloads do these new antennas extend out to? What does it enable the astronauts to control?
It's a system that's designed to communicate with payloads and hardware on the ELCs and the ESPs, the external pallets on the truss, and it's not a critical system that's required to operate those boxes today. It's an augmentation of the capability that we have today.
So, in regards to prioritizing going back and doing this task versus the other tasks that were scheduled on this EVA, do the antennas rank pretty high, or is it something that you could save for a stage EVA later?
It's something that could be done on a stage EVA, but in order to install the antennas, we have to take down one of our communication loops. So it's ideal to perform the task with the shuttle dock because we have their communication loops as a backup. So that's one reason we'd like to do it during the dock mission. And just purely in terms of priorities, it ranks higher than a number of the tasks on EVA 3.
Gina Sinceri, ABC News for Allison. Would you mind teeing up the next spacewalk for us?
Well, sure. So EVA 2, we have Drew Feustel and Mike Fink going out the door. There are two main purposes on this spacewalk. One is to perform the ammonia refill of that P6 PVTCS, the photovoltaic thermal control system that I spoke of. So we go out there, we hook up the jumpers, essentially the pipeline that runs out to P6. We initially start flowing ammonia from the port side ammonia tank assembly, and we do a leak check to verify that we have a good pipeline running out almost to P6. And then once we verified we have a good pipeline, we give Drew a go to start refilling the PVTCS itself. While he's working on that, Mike Fink is working on the port sarge relubrication. So he will remove sarge covers, 6 sarge covers, and he'll start the relubrication using 2 different styles of grease guns underneath that. So once Drew is complete with the fill, he'll then set up to vent the ammonia because we need to vent the ammonia from those jumpers. So he'll set up the vent tool and the vent tool extension, and then he'll start. Initially, we have a 17-minute vent, which vents the ammonia from P6 back to the P1 ATA. While that vent's ongoing, he stops by and helps Mike out for a bit with the sarge lube. Once the vent's complete, he then heads back outboard to vent the smaller jumper that runs to the P6 PVTCS. Once both crew members are complete with the venting ops and the sarge lubrication ops, they work together to restow the jumper that spans the P3, P4 sarge. So once they get that jumper stowed, both crew members move inboard and we start rotating the sarge 200 degrees, which sets us up for the second part of the sarge lubrication. While the sarge lubrication is ongoing, Drew is working on Dexter. He is installing a lens cover, a CLA lens cover on the camera on Dexter's latching end effector, and he's also using one of the same grease guns that we used for the sarge lube to grease the latching end effector. Meanwhile, Mike is working on installing the S1 radiator grapple bar stowage beams, which will be used to hold radiator grapple bars in the future. Once the crew members are complete with that task and we're done with the Sarge rotation, both crew members head back outboard to the port Sarge and work together to complete the second Sarge lubrication. They reinstall those 6 covers, and that wraps up EVA 2.
Okay. Any more questions here in Houston?
Philip Sloss with NASASpaceflight.com again. For Allison, for doing the replanning, I assume for EVA 3 for this to finish the EWC wireless install task, are you going to save that basically until after you get done with the second EVA? And then also, I assume the EVA crew are all cross-trained, so this would be different, slightly different EV crew.
Yeah, no, that's a great point. Yeah, so on EVA 1, it was Drew Feustel and Greg Chamitoff, and EVA 3 is Drew Feustel and Mike Fink. And so we were fortunate in that the number of, the extensive training that we've done, we've been able to add in a cross-training run. So all crew have been trained on pretty much all of the tasks. So we have to continually work in the EVA world. We never have a moment's rest. So while the prime team is focused on EVA 2, we'll have our planning shifts and other teams working on replanning EVA 3. So we were able to have a brief discussion with the crew today and kind of got some thoughts on where they would like to put the task. And once we understand from the program the overall mission priorities, we'll start working on that replan. But it'll be going on in the background during the EVA 2 preparations.
Seth Bornstein, AP. I guess for Derek, what is the bottom of the priority list in EVA 3? And essentially what could be bumped?
We got 2 main tasks on EVA 3. We're installing a power data grapple fixture on the FGB, and then installing the cabling, the 1553 data cable and the power cable to that PDGF. And we're also we're basically rewiring the flow of power from the US segment to the Russian segment by installing 2 sets of what we call Y cables. And the priority for the Y cable work is higher than the PDGF work. So again, we need to go off and look at the details of this and talk about the priorities and anything that's changed since we've launched. But it's likely that we would look at some of these the tasks associated with the FGB power data grapple fixture. We can for example, we can structurally install the PDGF, and then maybe we don't get the cables installed. Or alternatively, we can install a portion of the wide jumper. So, those are the kind of trades we need to do.
Okay, thanks. We're going to go now to our phone bridge calls and take questions from those reporters. Let's start off with Space Launch News.
Hi, good afternoon. Can you hear me okay?
We can hear you fine.
Thank you. Charles Axon, SpacelaunchNews.com, Examiner.com. For Derek, as the flight director, could you share your thoughts on tomorrow morning's special call from Pope Benedict XVI as His Holiness calls the space station crews from the Vatican?
Yeah, that this flight has been a series of firsts, and I guess we first started talking about this phone call a few weeks ago, and when we had the launch delay, there was doubts or questions about whether it would still happen. So I'm personally thrilled and honored that we found a way to make it happen. It's a pretty amazing event and a series of amazing events for 134.
Now, is this the first papal call to space?
I believe it is.
Okay, Charles, any further questions?
No, that's all. Thank you.
All right, we'll go on to Denise Chow.
Hi. I know you said that the timeline for EVA 2 would likely stay intact, but I'm just wondering if not having the cables complete for EVA 1, does that impact any of the tasks at all that will be carried out in the second spacewalk?
No, it does not impact any of the tasks on the EVA 2 timeline.
Okay. And just a note for clarification, did you say that the most recent time that you saw this issue of the CO2 sensor and excess moisture was on the ammonia pump replacement?
That was correct. That happened last summer. Was it July or August of 2010 was the last time that we saw this issue with the CO2 sensor.
Okay. Great, thank you.
I think next on our list is James Dean.
Hi, thank you very much. James Dean with Florida Today. Allison, regarding the Greg's oxygen recharge, that was described as being fairly common or not uncommon for a first-time spacewalker. Why is that?
And it's not just for first-time spacewalkers. It's basically, it's all based on your metabolic rate and just you as a human, how much oxygen you consume. So we see these O2 recharges happening quite frequently on EVAs. As the EVAs get more complex and we start running towards the end, sometimes extending beyond 6 hours and 30 minutes, we just on the ground like to be proactive and go ahead and get that O2 recharge to ensure that we have the most oxygen available to us. So it's not uncommon to see, and I don't think it's specifically linked to first-time crew members.
Thanks, and then just a couple questions about the EVA2 work with the coolant loop. I know it's described as a very small leak, and you're refilling about 5 pounds, I believe, of ammonia. Could you offer any more context on the size of this leak? I guess the capacity of this loop, how much you're adding to it, and how long that supply would last if you didn't refill it right now?
Yeah, it's a leak that's not likely to be observable with the human eye or with any of the video cameras that we have on the truss. So it's, I guess I would term it almost imperceptible in terms of what we can do with an EVA inspection, for example, or with any of the assets we have on the station. And I don't have the answer for the total capacity of the loop, but I can certainly get that. And what folks think is that if we were not to refill it, that something on the order of 18 months to 2 years, that the quantity of the loop would fall to a level where the loop would no longer be able to perform.
Thanks a lot. And then finally, I just wanted to confirm if the refill, is that triggered by the spacewalkers or down on the ground? And also wondered if you could just kind of refresh for us why ammonia is always such a tricky substance to work with out there.
You want to get that?
What was the first part of the question? The ammonia refill, is it triggered on the ground?
Being run by the ground, or do the crew members actually activate that?
Okay, that's a good question. It's a tag team between the EVA crew members and the ground. So the EVA crew members are the guys who are actually out there physically manipulating the fluid quick disconnects that run from the ammonia tank all the way out to the P6 PVTCS, but it's ultimately the Thor console position here on the ground that will open up the ammonia tank valve that will allow the ammonia to flow out to P6. So it's a coordination between the two. And your second question was on ammonia and why it's tricky to work with.
Yeah, it seems like fairly common when working with those lines to see some leakages, I guess, and some potential for the crystals, I guess, to contaminate the suits. And I guess I was just asking about the potential for contamination and why you have to be so careful with ammonia.
And that's correct. Yeah, ammonia is a hazardous substance, so if we were to bring it into the ISS environment, it would be hazardous to the crew. So we have procedures in place for the crew if they were to be contaminated by the ammonia or get ammonia crystals on their suit to perform a visual inspection and then help each other sublimate the ammonia off. And then we have calculations that we run on the ground to verify that they've sublimated all the ammonia off. And then we also perform a contamination test upon ingress before we enter the rest of the ISS atmosphere to verify that we've baked off essentially all of the ammonia that was on the suit. And traditionally, we've had issues with these ammonia tasks because the fluid quick disconnects are not so quick to disconnect, and it's a lot of moving parts, and they're kind of difficult to manipulate, and crystals can kind of get hung up. So we've seen quite a few crystals lately when we've been manipulating the fluid quick disconnects. So while we feel there is a slight chance for ammonia contamination on EVA2, the crew has been well prepared on how to deal with it if it were to happen, and then how to perform those contamination tests on repress.
Thank you.
Okay. We'll go on to our next caller, Chris Valdemar.
Yes, thank you. It's Chris Baltimore with Reuters. I realize these are early days for the tile inspection, but just a question for Allison. I reckon, are there any early plans or discussions about choreographing an additional spacewalk for an inspection should one be necessary? That's my only question. Thanks.
I truthfully can't answer that question because I've been focused on all the nominal EVAs. So we have what we call a Team 4, another team who's been off working on attending all the meetings and all the discussions and all the planning. So I truthfully don't know what discussions are in work there with that.
The thing that would happen before we went off and did a spacewalk would be what we call a focused inspection, which would be a closer look at the damaged sites with the OBSS and the other sensors that we have. And that decision has not been made yet. You'll get a briefing later today at, I think, 2:30 post MMT to talk more about tile damage and the direction we're headed.
Thank you very much.
Okay, I think that's all of our phone bridge callers. Do we have any follow-up questions here in Houston? Mark?
Thanks. Mark Carreau for Aviation Week. And I just wanted to go back to the sensor issue on the spacesuit. Is there a larger component you could swap for Greg Shamatoff so he can do additional spacewalks? I think he's assigned some more, and I just don't know what options you have to equip.
Yeah, and I guess initially to talk more about the sensor, this issue is kind of intermittent since it's water that's caught in the loop. We have in the past done what we've called a dry out procedure to basically run oxygen through that sensor, hoping it'll dislodge the water bubble. That's worked before in the past, so there are ongoing discussions with the engineering community about if that's how we want to proceed. And we've had other times where we've seen this issue on one EVA, and by the next EVA it's gone. So there's really no there's no way to tell if it's going to happen again on EVA 4. And as far as a bigger component, Greg wears a size extra large suit, and we only have one extra large suit on the space station. So there isn't another suit that he could swap into.
Philip Sloss with NASASpaceflight.com for Allison. Bearing that in mind, then, is there anything you can do sort of planning-wise going into EVA 4 then, in case this happens, to protect the objectives there?
Yeah, that's a great question. I think we would just have to make sure we understand. Like I mentioned, we were able to have pre-flight discussions with the crew and the ground team about breakout points for each EVA if in the instance we got into a case like this. So we've already had those discussions with EVA 4 talking about, as we saw today, once that CO2 sensor failed, it forced us to cut about 50 minutes off of what we thought we had for the EVA duration. So we would just try to stay on top of what tasks would fall off the end of the EVA, and we would just make sure that everyone is on the same page if that were to happen again.
Seth Borenstein at AP again. If the one before the EVA 4 starts, is there a way? Do you test the suit to make sure that can you test it to see that the sensor is working or not?
We don't nominally test it, but if we were to perform the dry out procedure that I spoke of, we do test the CO2 sensor at the end of it. I think there probably is a way that even if we didn't do that test, we could still basically turn the suit on the day before to see how the CO2 sensor was acting, but we haven't had those discussions yet.
And just to take the hypothetical one step further, you say you do this and you test it and it's still not working. Do you then send Greg out with a non-functioning CO2 sensor, or do you swap someone else in?
I think that would be a discussion we'd have to have. The CO2 sensor isn't required to go out EVA, as we mentioned. The crew member can be prime for detecting his CO2 symptoms, but as Derek mentioned, we do have a flight rule in place that tells us we need to subtract time off the end of the EVA. So if we went out the door knowing that we had a failed CO2 sensor, that would probably force us to do a shorter duration EVA.
Okay, it sounds like that's the end of our questions, and so we'll begin to wrap this briefing up. A few programming notes coming up at noon Central Time, 1 p.m. Eastern Time. We'll have today's post-International Space Station Mission Management Team briefing, and that'll be Kenny Todd, who's the Acting Operations Manager for the space station, and Courtney McMillan, who's the Team 4 Flight Director who's been working on the Soyuz photo opportunity planning. And then an update on our next briefing, which will be today's post-mission management team briefing. It's actually going to be at 2 p.m. Central Time, 3 p.m. Eastern, and that'll be with Leroy Kane, the Space Shuttle Mission Management Team Chairman. And so with that, we'll send you back to space.